Okay, let's talk about radians. So, a radian is just a different way of measuring angles. We grow up and we think about angles in terms of degrees, but degrees really have no natural counterpart in the real world. We made up 365 degrees in a circle. That has nothing to do with nature. We made that up. Radians are a different way to measure angles, just like we can measure distance in feet or miles or centimeters or furlongs. There are a lot of ways to measure distance. There are a bunch of different ways to measure angles. And the natural way to measure angles, the way the universe thinks, is in radians. And radians are defined in terms of arc length. So I want you to imagine here, we got this little circle here. And say we got this tiny little central angle, theta here. This radius r. And this arc length, the length of this little arc right here, s. Clearly, in the picture I've drawn, r is bigger than s. The radius, this length, is bigger than this length. Okay, what if I draw this circle? Now I've got this central angle theta, this radius r, it's an ugly theta. And this arc length s here. Clearly now s is longer. R is bigger than s. So you can imagine there's some special place here, maybe something like that, where this length here is exactly the same length as here. If you were to walk this distance, that would be the same distance as walking this distance. So here r equals s. We define that angle as 1 radian. So 1 radian is the angle, the central angle, when r equals s. So in general, if I were to say double my theta here, I would double my arc length. If I go 4 times the angle, I would get 4 times the arc length. Everything is proportional here. So in general, I'm going to write that a little prettier. In general, s equals r theta. Arc length is defined to be the radius times the angle in radians. Or a better way to think of it in this context is the angle in radians is defined to be the arc length you've subtended divided by the radius. And this is measured in radians. So what if we go all the way around? How many radians are all the way around? We know if we measure in degrees, a complete circle would be 360 degrees. What if I want to measure this complete angle in radians? Well, we know theta is just s divided by r. What do we call it when you walk in a complete circle? We call that the circumference. And we know that has length 2 pi r over r. The r's cancel. So 1 revolution completely around a circle is 2 pi radians. Or if we want to measure that in degrees, 365 degrees is the same as 2 pi radians. Okay, now if we want to convert between, if we want to go back and forth between degrees and radians, we could just think in terms of fractions. Or we could think in terms of proportions. So let me show you a couple things. What if I went halfway around a circle? Right there. There's my angle theta. Well, I could think, the way my mind works at least, is 180 degrees is just half of 360. So in radians, that angle in radians must be half of 2 pi. Remember, in a math class, the word of always means multiply. So this really means 1/2 times 2 pi over 1. Don't get stuck on the pi. The pi just comes along for the ride. Just think about these fractions. The 2's cancel. I get pi radians. 180 degrees is pi radians. What if I went a quarter of the way around? What if I did 90 degrees? That's 1/4 of the way around. That's 1/4 of 2 pi. So 1/4 times 2 pi over 1. I could do a little canceling here and get pi over 2 radians. 90 degrees is just another way of saying pi over 2 radians. And we can do this with pretty much any angle measured in degrees. Or we could give some formulas. So this is the way my mind works. I just think, well, what fraction of the way around did I go? Or we could set that up in a more general formula, and we could say our angle in degrees out of all the way around is that same angle in radians out of all the way around. That's a 2 there. Now, you'll see a lot of books, when they write down this formula, they like to cancel out a 2, basically multiply both sides by 2, and rewrite this as your angle in degrees out of 180 is that same angle in radians out of pi. And I'll do a couple of examples. You'll see that this one, there's a little less arithmetic to do, but it's harder to memorize. I think this one's easier to memorize. Your angle in degrees divided by a complete circle is your angle in radians divided by a complete circle in radians. Okay, so we'll do a couple of examples. Let's say we wanted to convert 30 degrees to radians. So I'll do both of those, and then I'll do it what I think would be the easier way. 30 degrees out of 360, I'm using this proportion right here, is my angle in radians out of 2 pi. So I could do a little canceling here that's going to make my life a lot easier. Cancel the degrees. I could even cancel the 0. 3 goes into 36 12 times. It says RAD right there. Angle in theta in radians. Now I'm trying to get this by itself, so I need to multiply this 2 pi up to the other side. This 2 pi is going to travel up here. So I get 2 pi over 12 is my angle in radians, and I can simplify that. 2 goes into 12 6 times. Again, don't worry about the pi. The pi just comes along for the ride. 2 out of 12 is 1/6. So 30 degrees is pi over 6 radians. Or I could use this proportion here. Mathematically, it's the same. I'm just going to have less arithmetic to do. My angle in degrees out of 180 is that same angle measured in radians out of pi. So 30, that's a 30, out of 180 is my angle over pi. 30 goes into 80 6 times. Multiply the pi up and we're done. Pi over 6. Or, so that was 2. Or, method 3, I could just use fractions. I know 30 is, say, for example, 1/6 of 180. Because 30 goes into 80 6 times. So that's 1/6 of the way there. So that means 30 degrees converted into radians would be 1/6 of pi. Because I know 180 degrees is pi radians. That's pi over 6. And we're done. So my recommendation to you, memorize one of these proportions here and always use that one. If you go back and forth between using these two different methods here, you're going to confuse yourself with where that 2 goes. So pick the one you like better and always use that one. But also, just think in terms of fractions. Most of the time you can just figure it out just thinking in terms of fractions. Okay, all of these angles here, we're essentially going to have to memorize throughout the semester. So we're going to go through a bunch of these today in this video. You either need to be able to memorize these or quickly come up with all of these angles, both in degrees and radians. So we can see here, like here's 0 degrees, 30 degrees, 45, 60, and 90. In radians, those are 0 or all the way around 2 pi, pi over 6, pi over 4, and so forth. Okay, we're going to spend an entire video just on arc length and area of a circle. I just want to point out here that radians are defined in terms of arc length. So if our angle is measured in degrees, we have to go through a bunch of work to find arc length. We had a whole video on it. If our angle is measured in radians, though, arc length is really easy. S equals r theta. But that only works if we're in radians. And I got a whole video coming on that. Okay, let's make this table here where we're going to convert a bunch of angles, a bunch of important angles into radians. So these will be 0 degrees, 30, 45, 60, 90, 180, 270 degrees, and 360 degrees. Some of these we already know. For example, we know 360 degrees is 2 pi radians, and we know 180 is pi radians. We just did 30 degrees is pi over 6 radians. Okay, what about 90? I think we just did 90 too, didn't we? Yeah, it's right there. 90 is half of 180. So pi over 2. So think in terms of fractions. 90 is half of 180. So in radians, we'll have half of pi. Pi over 2. What about 45? 45 degrees is half of 90. So half of pi over 2 would be 1/2 times pi over 2. The 2's don't cancel, they're multiplied. Pi over 4. What about 0? Well, 0 is 0. I don't care what unit you're measuring. 0 is 0. What about 270? Think about this. So I've got, if I set up my axes, here's 0, 90 degrees, 180 degrees, 270, and then if I go all the way around, 360. So let's just count by 90s. Here's 190, 2 90s, 3 90s, 4 90s. So 90 we know is pi over 2. 180 would be twice that, 2. pi over 2. Oh, the 2's cancel. We get pi. 270 would be 3 pi over 2. We can put that in our table. Radians. 360. We could think of that as 4 pi over 2's. Oh, well, look, we get a little canceling there. That's just 2 pi. We already knew that. We could use something similar to find 60. So we could use one of these formulas here. Way up here. I could use one of these to convert 60 into radians. Or I could just use fractions and the knowledge I already have. I could think, oh, well, 60, that's 1/3 of 180. (180) is pi radians, so pi over 3. Or I could think 60 is just twice 30. So 60 degrees is twice 30, 2 times pi over 6. Make that a 2 over 1, do a little canceling there, pi over 3. So 60 degrees is pi over 3 radians. Make sure you have this table in your notes. You really just got to memorize this. These are going to come up over and over again almost every day for the rest of the semester. You have to have this table memorized and understand it. The two you're going to have trouble with are 30 and 60. So I recommend thinking like this. Notice 30 and 60, there's 6's and 3's. We got all kinds of 6's and 3's floating around. They don't match up. The 30 does not go with the pi over 3. It goes with the pi over 6. 60 goes with pi over 3. Memorize it like that. That the 3's do not go together. The 6's do not go together. Okay, real quick, let's do one that's maybe a little harder. Maybe let's do 25 degrees. Let's convert to radians. Okay, now, like I can't do in my head what fraction of 360 25 is. If I could, I would just do it. So let's use our formulas. So we could say 25 out of 360 is that same angle in radians out of all the way around 2 pi. Or, and I'm going to do this both ways just so you can see it, I recommend in practice you pick one or the other of these formulas, and then I'm writing down the same formula. Pick one or the other and just always use the same one. I could do 25 out of 180 is that same angle out of pi. So here, let's do a little canceling. The degrees cancel. Let's see, 5 goes into top and bottom. So 5 goes into 25 5 times, and 5 goes into 360. $72 times. And that's my angle in radians. Multiply this 2 pi up on top. So 2 pi times 5 will be 10 pi. I'm going to not multiply those together. I'm going to say 2 times pi times 5 over 72. Because then I can cancel the 2 and the 72 and get a 36. So on top there's a 5 and a pi left over. We tend to write the number first and then the pi. So 25 degrees is the same thing as 5 pi over 36 radians. Or I could do this proportion, 25 out of 180 is my angle in radians out of pi. So again, I think it's easier to simplify this first. Let's see, 5 goes into the top 5 times. 5 goes into 180, I think 36 times. Yep. That's the angle I'm looking for out of pi. The pi just comes up on top. 5 pi over 36. So, like, you get the same answer either way. You choose which one you want to memorize and memorize it. And then my recommendation is always use that method. And that's a good place to stop.